Today you'll be setting up your ECQs on page IP20. Write the title, Periodic Table ECQs. Take out a page tab and stick it on this page at this time. Again, on page IP20, which is the right side of your science notebook, you'll create a T-chart like we normally do for ECQs. The left side is for your questions, and the right side are for your answers. You'll have 4 questions today. Go ahead and pause the video now to write down these 4 questions on the left side and make sure you leave some spaces for the answers. Turn to page IP21. The title is a periodic table and you'll need to set up Cornell notes for this page. Go ahead and pause and set up Cornell notes if you need to. You should also have a periodic table that's colored with 3 main colors. In my periodic table, the yellow represents the metals, the purple represents metalloids, and the green represents nonmetals. Make sure you've made a color code key so you know what each one stands for. The essential question for your notes is how do we calculate the number of protons, neutrons, and electrons in an atom? Now take a look at the periodic table you colored. There should actually be 3 colors only, not so many as you see here. Okay. Your periods go across from left to right, and there are 7 periods total. You'll want to label them. If you take a look here, period 1 starts here and actually goes across to helium. Period 2 starts at lithium and ends over here at neon. Period 3 starts at sodium and ends all the way at argon. Period 4 starts at potassium and goes all the way across this big block to krypton, and so on. Period 5, period 6, period 7. It reads just like your school schedule where your information for every period goes across, so it's the same thing. But it's important that you know how to read this on a periodic table. The very bottom ones are period 6 and period 7. So period 6 is part of the lanthanide series because it actually continues right here after lanthanum. And the actinide series is part of period 7 because it continues right after actinium right here at number 89. These elements are actually kind of squished right in between this area. Continuing on, groups go from top to bottom, and there are 18 groups total. You want to label them. 1 starts at hydrogen and ends all the way at the bottom at francium. Group 2 starts at beryllium and ends at radium. Group 3 starts at scandium and goes all the way down. Group 4, Group 5, and so on, all the way to 18. You might want to write G1, G2, G3, G4, all the way to G18 so that you know this represents groups. Groups go straight down, and sometimes they're called families because all the elements in the same group actually kind of act the same way, just like, well, a family. So for example, group 18 are very non-reactive, and they don't blow up, they don't explode, they don't catch on fire. Everything here on group 18 are very stable elements, and they tend to be gases. So we call these noble gases, and they don't do anything special, but they are very neat. They have very interesting properties, and we'll talk about that later. All right, we're going to turn back to our notes, and you can begin. Okay. Number 1, atomic number tells the number of protons. Each element has its own atomic number. So for example, helium has an atomic number of 2, so that means it has 2 protons. Draw this picture and label all 3 parts. Highlight where the atomic number is found. This is a periodic table square, and you have the atomic number or the proton number on top. So right here 2 means 2 protons, because that's the atomic number. The capital H and lowercase e is the elemental symbol. It always starts with a capital, and if there's a second letter, the second letter is always lowercase. So make sure you write that correctly. The atomic mass is 4.003. We'll talk about that later. In a neutral atom, the number of protons equals the number of electrons. So because remember, protons are positive, your electrons are negative, so if there's the same number of each, they actually balance each other out, and that's a good thing. You don't have to draw this picture out, by the way, because it doesn't say the label. The atomic mass tells the number of protons and neutrons put together. You always round to a whole number when we talk about this to calculate, and C, to find the number of neutrons, you subtract the atomic mass minus the atomic number. So, for example, helium has an atomic mass of 4, right here, 4.003, so we round it to 4, an atomic number of 2, okay, up here on top like we said earlier. 4 minus the 2 means that helium has 2 neutrons. Okay, so this is how you calculate. Draw and label this picture again, and this time highlight where the atomic mass is actually found. For atomic mass, remember this is about the weight of the atom, so the protons and neutrons are in the center nucleus, which is very dense, if you remember from before. It's very heavy in the middle. The electrons are tiny and they don't weigh a lot, so their weight doesn't really count for the weight. So that's how atomic mass is made. Protons and neutrons, heavy in the nucleus, and it makes this weight. All right. E, isotopes, a new word, means an atom of the same element that has a different number of neutrons than expected. You want to draw and label this in your notes. These are isotopes of hydrogen. The first one is a normal hydrogen atom. We actually call it protium, if you want to be specific. Protium, or normal hydrogen atom, has just one proton, and it's balanced by the one electron, right? Positive and negative, but it has no neutrons at all, right? Okay, so that's normal, okay, for hydrogen only. Deuterium has one extra neutron. So if you look here, there's one proton, one electron, one positive, one negative, they're balanced, but then you have an extra neutron. So it makes it a little heavier because now there's two big things in the middle. Okay. And tritium has two extra neutrons. That means there's protons and electrons like normal, one of each, and now there's two neutrons in the middle, so it makes it even heavier. Tritium is a heavier atom than deuterium. Deuterium is heavier than the normal hydrogen atom, which does not have any neutrons. Okay. So deuterium and tritium are isotopes of hydrogen because they have different numbers of neutrons. That's one of your ECQ questions, by the way. Now at the end, create just 2 questions. You may choose any of these 2 words. Please don't repeat and do not use what questions. So you can use compare, name, state, analyze, or how. Pause the video now to make your questions before you continue. Now go back and make a key for your highlighters at the very top right corner of your page. You should have a color for vocabulary, another color for definitions, and a color for facts. At this time, you should also go back to your notes and look for all the vocabulary words. Look for keywords and highlight them in one color. Then find its definitions and what it means and highlight that in another color. And last but not least, any other facts you think that I would probably give you a quiz on. You might think about the ECQ questions because those questions are guaranteed on your quiz. For your vocabulary and summary, on the bottom left corner, for your vocabulary, find the 3 vocabulary words and write them down. There are only 3. In your summary, answer the essential question in 3 to 5 sentences, and number and highlight your sentences. Remember, the essential question was, how do we calculate the number of protons, neutrons, and electrons in an atom? So go back in your notes and find out. To calculate the number of protons, we would, and to calculate the number of electrons, we would do what? And to calculate the number of neutrons, we would have to, and finish that sentence. That's an example of what you could do for your summary. When you're done, you're done. That's it, okay? Double check your notes, make sure everything's done, and make sure you get your notes signed off by your teacher. Oops.